We're going to look at solving quadratic equations today. Solving an equation means figuring out what values of x would work to make this a true statement. When we look at a linear equation, this is a fairly simple process. Remember, just get x by itself, and then you have the value of x for which this is a true statement. A little algebra here, the x's all on the same side, and move everything else to the other side. 3x minus x is 2x. 11 minus 7 is 4. We want to know what the value of 1x needs to be for this to be a true statement. So we'll divide by 2. And x is equal to 2. This is the solution for this linear equation. When we plug 2 back in for x, we get a true statement. 6 plus 7 is 13. 2 plus 11 is 13. 13 equals 13. Linear equations are very simple to solve for x. For a quadratic equation, it's a little different. We can't just get our x on one side and solve for it because we have two different types of x terms. We have an x squared and we have an x. So it won't work the same way as a linear function. We need to do something different. In order to solve our quadratic equations, we're going to rely on one principle that two things being multiplied up to 0 gives us a pattern that we can utilize. The pattern being that either m is equal to 0, one of our factors of this product is equal to 0, or n is 0, the other factor of this product is 0. The only way we can multiply two things to arrive at 0 is if one of them is 0. So using that principle, and the second, which is that we can factor quadratic expressions, that's going to allow us to solve for x, solve these quadratic equations. So here's how it works. We're going to take our quadratic equation, and we're going to get everything to one side. We're going to rewrite it in a way that looks familiar. In this case, it's a quadratic trinomial. 2x squared plus 6x plus 4. And on the right side, we have 0. This allows us to factor the left side into two sets of parentheses. And those two sets of parentheses are going to multiply up to 0. So if each of those sets of parentheses is equal to 0, we can solve for x. How do we factor this? Step 1, GCF. Step 2, look inside. We have a quadratic trinomial. A is equal to 1. We'll use the trick. Right? 1 times 2 is 2. 1 plus 2 is 3. At this point, we have two factors equal to 0. The 2 will never equal 0, so we don't have to worry about it. We can just look at the parentheses, this and how they're multiplied up to 0. That tells us that either x plus 1 is 0. It has to be in order for this product to be 0. Or, if it's not, x plus 2 is 0. And from these new equations, we can solve for x. Subtract 1 from both sides. X is either equal to -1. Subtract 2 from both sides. Or x is -2. Again, we're utilizing the fact that two things multiplying up to 0 means that either one of them is 0. And a quadratic trinomial, or difference of squares, is easily factorable into two sets of parentheses. We solve for x. That means that these are the values of x for which this statement is true. We can plug them in and check. -1. We plug them in one at a time. So if x is negative 1, we get positive 1 times 2 plus 4 is positive 6. And negative 1 times negative 6 is positive 6. That's a true statement. Or negative 2 is correct. We'll plug negative 2 in now to check it. Negative 2 squared is 4 times 2 is 8 plus 4 is 12. And negative 2 times negative 6 is positive 12. That's also a true statement. So solving a quadratic equation is a little more work than a linear equation. It requires the factoring process, and it requires setting up two equations from your factors to solve for, in this case, two solutions for x.